Hello, everyone, and welcome to the Passive House Accelerator Live, where we explore how to slash the greenhouse gas emissions from our buildings and make them more resilient to the impacts of climate change. I'm Zach Semke, Director of Passive House Accelerator, and I'm excited to welcome Ace McArleton of New Frameworks to speak about building with straw-insulated panels at the Casitas project. Our co-hosts of today's Project of the Month are Shefali Songvi of Datner Architects and Bev Craig of Mass CEC. And with that, Bev, please take it away.
Welcome, everyone. You are so in for a treat, and I am so excited to hear Ace because I've been a huge admirer of the Casitas for a while, and I gotta say, I'm excited about them as accessory dwelling units in Massachusetts coming up soon. We are now going to be transitioning to our presentation portion, so I'm going to hand it off to Shefali to introduce Ace.
Thanks, Bev. Welcome, everyone. If you're from New York, I hope you're enjoying this hint of spring that we are seeing. It was really nice yesterday. It's a little less nice, but still really nice today. I'm really excited today to hear Ace talk about his work as co-founder, co-CEO, and director of vision and strategy at New Frameworks. New Frameworks was founded in 2006 to offer design build services that blend natural materials and methods with high performance design, moving the building industry towards climate regeneration and social justice. My introduction to New Frameworks was seeing Jacob do a talk at the New York State Green Building Conference in Syracuse, I think last year. And then ever since then, I've really been big fans of all the work that New Frameworks is doing, to the point where Ace and Jacob came to our office last fall, and talked about this. So I'm really glad that you all get to hear what we heard yesterday, and can't wait for the really inevitably exciting conversation that's going to happen. So with that, Ace, please take it away.
Thank you. Thank you, Shefali, so much. And thanks for the warm welcome, everyone. I'm really glad to be here. So I'm going to go ahead and share my screen, and we can just dive right in. I know everybody's excited to get into the details. So just very briefly, Ace McArleton, I use he, him pronouns. I'm one of the co-founder and co-CEO of New Frameworks. And I'm going to just walk you through this project that we began, and why, and what we're hoping to do with it, and hoping that we can help everyone here join the movement for bio-based material scaling, which is what we're going for. So we have our prefabricated. So we began creating prefabricated straw bale panels as a way to scale and make more easily replicable and applicable natural building technologies like straw bale construction. So I started working with straw bale construction in the Northeast United States in 2002, 2003, and learned from some of the earlier industry workers like, my gosh, I'm totally spacing on his last name, Paul. It'll come to me. He's amazing. He wrote one of the early books that was a big inspiration for us. But learning from those early adopters in the Northeast and learning what the strengths and weaknesses were of these natural-based materials and how to properly apply them in a wet and cold climate is really the basis of Jacob, who some of you mentioned, Jacob Rakusin, my business partner, who co-founded New Frameworks with me. What he and I have really been focused on is how do we use these wonderful materials. I think many of us can understand, like, these have great properties. You know, they're non-toxic. They are often byproduct from agriculture. You know, they draw down carbon naturally from the atmosphere. They're often healthy, you know, for interior air quality. We have easy end of life stuff that's very, you know, healthy for the planet, healthy for people, et cetera, et cetera. It's all good, good, good. What has always been a challenge with these materials is how to work with them in a way that makes the labor portion of it easy and makes sense, which can help keep costs down and also help to make it more scalable and applicable to commercial projects, multi-unit residential projects, etc. So after being inspired by Chris Magwood's work with prefabricated straw panels, if any of you know Chris, I'm seeing some nods. Chris's books are awesome, and I would encourage you to take a look for them and to follow his work at Rocky Mountain Institute now, and also co-founded Builders for Climate Action, along with also Jacob, my business partner, who's busy. He gets around. Anyway, Chris inspired us to really begin with straw panel. And for us, it has become kind of a no-brainer. So we went from prefabricating straw panels to seeing that in order to actually meet the housing crisis demands that we have, and all of us are seeing it, right? All across the country, the housing crisis that we're in and the affordability crisis as well, combined with the climate crisis, we need a solution that's going to easily put all those pieces together. So from that, we created the casitas. So I'm showing you two here. I was joking that this is kind of like a casita for every season because we've got the snow, we've got the green, like it's lovely. But these are two, and then a third that we've created locally here in the Burlington, Vermont area. These are, just a few shots of interiors. We're focusing on, so these are straw buildings made of structurally insulated straw panels, so SSIPs, and we are applying those in a panelized way to put the entire building together. From the floors, which are insulated raised floors, and we'll get into the details because I know everybody here wants detail nerd stuff, which is awesome. So the floors are panels, they are super insulated. The walls are panels, super insulated. The roofs are panels, super insulated, and everything goes together like a Lego kit. And then we attend to all our details because the other piece of using natural materials in a high performance way is that in order to make them durable, we need to understand them from a building science perspective. How does moisture move? How does heat move? What are the dynamics? How do we keep these materials in good shape for the long term? And that's about building science and knowing our enclosures. And I know I'm speaking to a group here who knows very well about that from within the Passive House community. Just a few more shots of the interiors. So we're focusing on healthy interior materials. You're seeing lime plaster on the walls. So that's locally sourced lime mixed with limestone sand from a local quarry that we apply as an interior finish. All of the wood finishes are, non-toxic wood finish material as well. And we're all getting most of our our lumbers from local mills as well. So we're really looking at how do we bring this to connect with our place-based economy and make sure that we're working that entire life cycle and chain. So this just tells the story a little bit. Okay, why did we do this? Basically, our company has been, so I founded New Frameworks in 2006. I was working in the industry for up to 5 years prior to that. And from 2004 through 2019, we built an average of 1 to 2 homes a year using these materials. Great, fine. This is an example of a straw bale timber frame home that we built. Essentially, people would put up a timber frame, we'd wrap it with straw bale, we'd plaster it. Great. The amount of labor that took and the sort of bespoke and non-replicable nature of that, and the amount of kind of trades education that was required to achieve that, made it clear that if we're talking about scaling a solution to meet the scale of both housing and climate crisis, as I mentioned, that was not going to be the path of least resistance. So building an average of 5 straw panel homes and buildings per year since 2019, when we launched our panel division, building straw panels, has just really given us just a tiny taste of what's possible if we actually start to look at how we can scale these things, thinking about ease and production and getting these out easily into the marketplace. So this is an example of one of our casitas again. This is called the Casita Terra. This is our 600 square foot model. And, this is just a cute little chart because it's fun to show things visually, right? But like this gives you a good sense of the amount that we have been able to scale our impact in just a very short time of moving into this panelized realm. I put this up here, I'm based in Vermont. Obviously, many of you are all over the country. Everybody's seeing this huge need for housing. And I know, Beverly, you spoke about, ADUs and max and some of the things that are being done there. I know many states and many municipalities are really looking at this issue. The role of ADUs in addressing this housing crisis, right? We're also densifying our neighborhoods. So we're utilizing existing infrastructure. When we're talking about understanding climate challenges and carbon, when we zoom out even further from just buildings, right? We're looking at transportation, we're looking at walkability, we're looking at what's already been invested in these infrastructures to support human life and to support it in a way that's going to maximize that investment and minimize our carbon expense. So all of that is really important there. I think another piece that I'll mention is just the intergenerational family living and, you know, chosen family and community living. I mean, we've seen that's been actually a huge part of our market, is people saying, all right, I have this property, I have this piece of land. How can I provide more for my family, for my neighbors, for my friends, for my community? So that is a part of the casita approach. Fast schedules is the other thing, you know, which goes with the housing crisis, which goes with affordability and accessibility. And then also with just the logistics of putting these things into an urban setting where you're going into lots and you're disturbing neighbors and you're backing in and out of driveways and all that sort of stuff that's just about the logistics of achieving a build. The schedules are so attractive to us, you know. So again, we came from the like bespoke kind of custom, every single design is different. You know, we were and still could be a design build general contractor, you know, following the entire project through from design all the way to completion. And the kinds of schedules that we saw don't touch this. You know, we're able to be very rapid because we have pre-designed these, we can prefabricate them in the shop, and then the site time is very, very efficient. The other piece, and just maybe before I jump into cost, the other piece is, I mentioned the interior finishes. Why we've fixed the interior finish specifications is so that we can actually also achieve those very rapidly and not actually have to rethink and stop and say, oh, how are we going to do the trim here? And what's our, you know, no. Let's just, it's all figured out in advance. And it was a part of us saying, how can we offer, what is the best gift that we have to offer of what we've learned over the last 20 plus years doing this work of high performance natural building? Let's just offer our best thing that we have to offer to this moment. So that's sort of what the casitas are. We're doing two things with them. We're doing a kit only, where we're able to fabricate and then send the whole enclosure, the whole kit, anywhere in the country. And we've actually had inquiries from Canada as well. And then allow the local builder or local homeowner or whoever it is to finish it out and to assemble it. So that's been a really fun way that we're working to scale this technology and this approach, and keep those costs very accessible. And then in terms of our general contracting service, which we're able to do if people are in our area, we've been really working to get those cost per square foot numbers down, you know, per unit. And when we're at the small units, we are a little over $400 a square foot. As we get down to our larger units, we can really get that cost per square foot down for high performance, natural carbon storing, all electric homes. So I'm just going to go, you know, through this in a way that we can touch on things, and then I want to make sure we have time for questions. To me here, and I know many of you are here for this reason, but to talk about this theme of, we have these two combined crises that actually provide this incredible opportunity for us to build the world as we want to see it, and to build a healthy and fulfilling world for all, and all beings, not just humans, but also all the beings that we're in connection with on our planet, right? Who we depend on and who depend on us. So when we look at the net emissions that are possible from our low-rise residential units in the US, I mean, it's just an incredible amount of potential emissions that we have just from the work in low-rise residential. And I know there are people here who work in other spaces as well. This is just a helpful thought experiment. If we did the worst case scenario, we'd be looking at 83.4 million tons of CO2e, equivalent of about 23 coal-fired power plants being online. And if instead of using high emitting embodied carbon materials, we do our high performance awesome homes with carbon storing materials, we hit this best case scenario where we're actually removing emissions from 10 coal plants from the construction that we need to do anyway to house people. So this is where I'm like, this is a no-brainer. We need to be doing this, right? So plants capture gaseous carbon from the atmosphere through photosynthesis. They also sequester some of it in the soil, and that's not currently counted in any of our numbers. Embodied carbon of materials, this is just a very quick kind of visual. But one of the reasons people always say, why straw? It seems like kind of this difficult thing to build with, like there's these other options, like why would we do it? I mean, one of the biggest reasons that Jacob and I have focused our careers on it is because it's one of the best storers that we have. Hempcrete is also awesome. Wood fiber bat, I mean, there's a lot of these things that are good. We could use them, yay. Like, it's not about a competition, but it's about let's maximize. When I have spent my life learning how to work with this material and it's the best storer, that's what I want to offer. Again, that's like my best gift right now that I can try to give to the world with my time and my life. So this is using the beam calculator from Builders for Climate Action, which I'm not sure if everyone here is aware of, but I encourage you to check it out and do a search and look at it. The idea is to put into the hands of the people, into the hands of all of us, the ability to calculate our own embodied carbon of our project. So you can run your project through this tool for donation basis and find out, okay, how's my building doing? If I chose a different foundation material. And I can actually give an example. I wish I had done this, but we have an example of running this project with doing a slab foundation instead of a pier foundation. So we have these on a pier foundation, as I said, and then an insulated floor box. So these are raised off the ground. And we did that on purpose. And it's because of the carbon. When you do a pier foundation, we can actually have a carbon storing building, a net carbon storing building. So that means that with all of the materials added up, we are actually drawing down carbon rather than emitting it at the end of our building construction. And when we add a concrete slab to this design, it actually becomes an emitting building. And many of us here are familiar, concrete is a high emitter. And I guess I just want to say, I am not anti-concrete. There are moments and times when we need it, and that's great. It's about let's spend that when we need it, for people who need a single level building for whatever reason. Let's use that for our full foundations. Let's use that for the moments that we just can't find another solution because it is such a high emitter. But then where we can, let's not. So that's just one example. And so if we run on this list, looking at material carbon emissions by section, we see that the exterior walls, right there, all the other items were low carbon, relatively what we chose. And then our walls are storing. And so that helps give us that net result that we're really looking for. Chris Magwood, Jacob Rakusin, and I gave a 2019 keynote at the NESE Building Energy Conference in Boston. And this was one of our final slides during that presentation. And we were sort of exhorting the crowd and all of us to look at our own practice around embodied carbon and combining, high performance buildings with low embodied carbon or carbon storing materials. And this was the challenge that we sort of laid down to the NESE community that year. We said, if we look at high carbon being here, moderate carbon, best conventional, which by the way is just using off the shelf products, even back in 2019, using cellulose and wood framing and just doing a little bit less, like not choosing the hardy board siding, and instead choosing like a local wood siding or whatever. We said, look, in the next 5 years, and this was in 2019, let's start doing this. Let's start doing these drawdown buildings. And I have to say that when I went back and I put this presentation together, realized, oh, that's what we're doing with the casitas. We're trying to do that. We're trying to meet this, do this in the next 5 years. Okay. So spoke a lot about carbon, but obviously there's a lot of other stacked benefits when we use bio-based materials. We are also caring for humans around health, comfort, and safety. We're not using binders, there are not treatments, there's no petrochemicals, there's no additives. That's actually my youngest sitting there on the straw panel in our shop. And that's Eve and Marina and Jose in our shop here in Essex Junction. High performance enclosures, which again, I'm sort of speaking to the choir here, but superior comfort and interior air quality. It is shocking when people are like, wait, but don't I need, radiant heating? I'm sure you all have these conversations with folks a lot if you're in the high performance world, right? And trying to explain to people that like wood stoves and a radiant floor, you're going to be so hot. It's so hot. So when we have superior comfort, when we have these like amazing enclosures that are very airtight and have very high R value, et cetera, we attend to our transitions and our fenestrations and all these pieces. It's a very different experience to live in that home. And then the durable vapor and liquid water management, that's just been key to our practice from the beginning. I hope people in the chat are asking, what about water? What about fire? What about pests? What about, because those are all the questions that are very appropriate to ask and are also, easily addressed when we look at the history of this material being used appropriately in a challenging climate like the one that I live in here. Fire is the other really fun story, but I saw that you all did something about that very recently. All right, so I'm going to get into panel details again because I want to keep myself tight here to give time for questions. I'm going to run through these quickly. So this is just this is not rocket science. I just want to say that really quickly. We are doing this on purpose, very simply and very replicably, because the idea is let's get these out to as many people as possible as quickly as possible. So this is not a secret thing. We're not hiding our IP. This is about a durable double stud box with cellulose in it. Cellulose insulation, which is straw. And I guess I'll say that quickly. Straw is the woody stalk of the cereal grain plant. It is akin to, you could think of it as like the trunk of the tree. The top of that plant is the nutritive part of the plant where the seed head lives. That is harvested first. And the bottom of that plant is the stalk. It is woody, and what it is made of on a like molecular level is cellulose and lignin fiber, which is exactly what wood is also made of. So you can think of straw as like thin tubular wood, basically, in a package. So that's what we're putting in between, this double stud box. And then we're attending to our, interior air barrier and layers, and then exterior air barrier and layers. It is sealed on all 6 sides. So we're looking at, 6 sides air sealed, and then vapor open. And so I can get into more of that as we continue. So there you can see, our air barrier, the bales, exploded little diagram there, sheathing to the exterior. Sample layout, you can see we create our windows and doors by basically the negative space in between the panels. So the 2 vertical panels, the sill panel, the header panel. You can see a little bit of a window plan detail there. And again, we can come back to details in the questions. So I'm going to run through this quickly. We get our straw from Aurora Farm in Charlotte, Vermont. They also run the Nitty Gritty Grain Company. So it is super fun. You can go to the store, you can buy a pancake mix, you can make it in the morning, and you can make it in your straw house that was built with the same plant that you are eating your pancakes from. So it's pretty cool. We like it. It's organic. Again, here's the process of the baling and harvesting. Our farmer brings a load to our shop. We unload in the back of the shop. We bring it down. We work with any of our designs, whether it's our own pre-designs, or we also do panelized orders for other people's custom designs as well. So we have our shop drawings in the shop. Our team cuts the framing package and preps the framing package first. We have a table that we designed and built in collaboration with a local metal worker here in Barrie. It's very simple. The techniques are not complicated. And we compress each layer of straw bale that we put in. And then we finish it when it comes off the table, clean it up. We do this little end, so you can see there's a stud, and the bales actually stop the interior of that. They do not penetrate into that cavity between the 2 studs on the end. And we will put in instead a strip of wood fiber board or other insulation, but we like wood fiber board. And that is what the panel looks like when it's done and when it comes off the table. And We also use timber HP currently, which is a wood fiber insulation. We're using a lot of the blown in to do our roof panels, floor panels, any of the like oddly shaped or small panels that don't make sense to use straw. We do also use plaster. So this is an example of us doing a base coat of clay and lime plaster in our shop that we can then ship to site. And then on site, and you'll see some photos of this, you essentially tape those joints just like you would in between sheetrock and then do a finish coat over the top. This is an example of our shipping process. And I will just super briefly say we we're creating something called the Seed Collaborative, and a training program that's a startup program. And we trained 2 companies last year, one in Massachusetts and one in Missouri, to build panels the way we build them. And they are now up and running and offering those panels from their locations. And we now have a new cohort joining for 2025. And we have somebody from Washington State. We have somebody in Maryland. And what is the other one? It'll come back to me in a moment. But so we're just really excited because on the note of trucking and shipping, when we talk about transportation carbon, we are not looking to become the like nationwide supplier of straw panels. Rather, we would like to see these practices seeded across the country and across the locales. Installation, you can install with a telehandler. You can also, not with the casita kits, because the floor panels are too big and the roof panels are too big, but the wall panels are possible to tip up with like 2 people in a dolly, which is pretty cool. And we've had customers do that. So this just shows you a little bit about how we prep. So we have, you can see the screw pile foundation underneath. We use local timbers to create a timber kind of floor frame that then the insulated panels get set on top of. And this gap that you can see cut in this floor panel is for the utility entrance. This is showing an example of what I was saying of the pre-plastered panels getting put together on site. And then this seam in between the panels will be essentially mudded and taped, but with a natural plaster. And you can also see a little bit of the high performance tape that we use to treat the edges. This is kind of a cool thing that I won't go into now, but in the question session, if people want to talk about plaster, natural plaster with clay and lime as a high performance air barrier, that is one of the biggest, coolest nerd things that I like to talk about, because it's pretty interesting that we can do that we can like liquid apply some like local minerals and make an air barrier that's very high performance and inspectable, repairable, democratically created. It's pretty cool. I love this one because Lily's, got her double thumbs up there. This is us putting together actually that little yellow casita that y'all saw in the earlier picture in Burlington, Vermont. And we don't have to plaster. I have been surprised by the demand and interest. I will be honest with you. I thought, oh, this is kind of a niche thing. Not everybody's going to be interested in it, but I've been very surprised by the number of people that are very interested in plaster as a wall finish. We have moved towards, rather than having it be a bonded system to the straw, actually doing a strapping cavity for chases and then applying drywall, or we're now going to start looking at using this wood fiberboard in place of drywall and then plaster that. But I'll walk you through that in a moment. So again, just some shots of installation. You can see the roof panels here with their fun angles about to go up. A little bit more of those details. Again, I'll spend more time on that if we want to dig into it in questions. So I mentioned the utilities. This is, pretty simple. It's essentially like a septic riser that we insulate. All of the services and utilities have been trenched back, put below frost line, and then come up through an insulated chase into the floor. And then we, circulate it within the building once it's inside the thermal enclosure. And the beams that you see are outside of the thermal enclosure, and then the floor panels create that thermal boundary. Just a little shot into that utility hatch. One of the fun and not so fun things to figure out has been trying to figure out how to get proper pitch on all the plumbing when you're in such a small enclosure and you have one spot that you're bringing it to. It's been really challenging. And we've solved it in a couple different ways. But so I can go into that more if folks want to kind of nerd out on that. But that's just a shot of a raised floor. So we are doing currently a raised floor on top of those, the thermal boundary floor panels that I showed you. But what we're looking at doing, we've been looking at a couple different solutions of depressing that into the floor panel and figuring out if we can either add more insulation below that or how we can make up for that, or so anybody wants to join the brainstorming session, I'm always for it. Here's just again, y'all know what the inside of houses look like, and this is our very busy service wall in between the bathroom where the utility hatch comes up and then the kitchen. All right, so I mentioned the service cavity. So this is something that in terms of scaling, right, we're talking about, okay, bonding clay lime plaster to straw and then detailing it as an air barrier is not something that our trades are, across the country are yet ready for. Maybe we will be someday. But in terms of making this very transferable and scalable for folks immediately and accessible, providing these as with a service cavity. So I don't know if anybody can kind of make out the beautiful shadow of the straw behind the Intello, but it's behind there. So we put Intello across the face, then apply a strapping cavity, and then that becomes the chase for electrical, which is conventional. Our electricians are like, "Ooh, thanks. Okay, this is great." They're like very relieved. We could see the plumbing here for the sink in the kitchen. So this ends up just being a very conventional, easy to do approach. This is just a very quick run through of what we would do and what we have done in the instances when we have done the straw bonded system, plaster bonded to straw system, is we essentially create the same thing. It's like a little baseboard chase that is a little area, then we just cover with a baseboard, and then you can open it back up, you can run your lines through. And this BX cable was actually not necessary. It's just something that the electrician was like, we'll just do this just in case, but it wasn't actually fully necessary. But that's all right. Sometimes we have a built-in suspenders approach, and that's fine. All right, so I'm wrapping up here because again, I want to leave time for questions. But this is showing how in one of these little cabinitas, we're detailing. We're using combinations of these awesome high performance products that we have, for example, from Proclima and other providers. This is a fleece tape that pairs well with our plaster called Contiga. Just showing you some other details. This is going into a adjoining little framed wall popping out of that baseboard there. This is the kitchen, so you can see sort of how the finished plaster looks when it goes over the base coat. And then that's exactly how that finished out. So I can just back up for a second. So you can see, we're running electrical here. The cabinet will get hung here. This is the lower cabinet. And that's how everything finishes out. This is also how that earlier photo that I showed you of the strapping near the door with the electrical, how this finished out. So this is that lime plaster actually onto drywall on the outside of that chase. And I think it's fascinating that you can't really tell the difference between the bonded one and the drywall one. They look the same, but they're just the layers beneath are different. This one's just showing, our all electric approach. So we're not using any fossil fuels for anything in these. And we do have full ERV systems for interior air quality. This just shows a quick example of taping that seam like I talked about with plaster to kind of bring a single surface prior to adding that finish coat. So it's just showing us pre-plastering those panels in the shop. Again, another little shot of that detail. And that's how it finishes out. So I'm right at the end here. I'll just spin through photos and then I'd like to open it up for questions. So there again, our casita. And these are, as I said, designed to be airtight, high performance, all electric, good interior air quality, etc. Here's our bathroom. Actually, I should have a picture of our little floor hatch. So how you all saw that this was where the utilities come through. There's a floor hatch that's you can't really, I mean, you sort of see it. There's a little, like as if you were on a ship, there's a little ring that you can grab and lift up the thing, but it just fits seamlessly into the floor. So that's how that finishes out. And I think that brings us to completion. I just want to thank you all so much for your attention and interest, and hit me with questions.
Thanks so much, Ace. Wow, this is like incredible. I just want to see that like adoption rate go through so high, so fast that like we're all just going to be next year like, how did this happen so fast? And it's so encouraging to see these other seed manufacturers taking, you're just sharing this information and jointly doing this. It's like just so inspiring. So I think we're going to quickly go for our sponsors, and then we'll get back to the question and answers. There's a lot of great questions.
Yeah, thanks, Bev, and really amazing, Ace. Thanks for sharing all of this. So a big thank you to the fine organizations that make our work here at Passive House Accelerator possible. Thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you also to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. And thank you to our champion sponsors, Bewizo, Cascadia Windows and Doors, European Architectural Supply, Facro, Icon Windows and Doors, Intelligent Membranes, LG Air Conditioning Systems, and Source 2050. And thank you too to our patron sponsors, Building Type, Brennan, Holstrom System, Inotech Windows and Doors, Lamelux, RDH Building Science, and Sanderson Sustainable Design. Thank you, sponsors.
Thanks, Zach, and thanks, Ace. This is, again, just fascinating stuff. So we're going to try to get through as many questions in the next 10, 15 minutes as we can, but if you can stick around till 1:15, Ace is available till then to get through all the questions. So up first, Shannon, are you on? I think you had maybe 2 questions, so if you're on, feel free to unmute
You
and
asked
ask
me
your
to
question.
ask them, but I'm having trouble locating them. There was one about the foundations, I remember.
Oh yeah, I can ask them if she's not here. So
No, I can unmute.
yeah,
Thank you.
please go ahead.
Yeah, I was curious about the foundations. Ace, great presentation. Always love to see your work and hear your thoughts and your process. So thank you. The foundation is cool. It's really elegant and it's low impact. Wondering if you can talk a little bit more about that process, how you arrived at that foundation system, and if you ever considered wood piles.
Yeah, definitely. So in our history of our company, we've tried a bunch of different concrete-free foundations or just different approaches to foundations. We have done, I'm trying to actually think now that you're saying that, if we've ever done like for a project, like for a customer on a project, done a wood foundation like what you're describing. I experimentally worked with timbers that were treated for like a foundation, for a pier foundation through Yestermarl, but I don't think I certainly didn't reach the point where I felt comfortable enough to say, yes, let's do this for a customer and for a project. But the screw pile foundation we use a company called Technometal Post. They're a, kind of like a franchise nationally. We have a local person who operates that franchise who's great. We got to it because we had used the Technometal Posts and the piers, the piles, for some of our custom projects. They're conventionally used for like decks and things like, maybe an addition, stuff like that. People may be familiar with them in that setting. But it was through using them that we really came to appreciate, one, how well they work, how quick they are to put in, the least amount of site disturbance that happens as a result. So we spoke about the ADUs with the casitas, and one of the really appealing things is that the little machine that is used to install these is small and can maneuver easily. So you're not trying to get, a giant excavator into somebody's backyard and like dig up an entire area in order to put the foundation in. So, disturbing less plants, soil, ground, neighbors, access, all that stuff. So that was a huge part of our move towards that direction, in addition to the carbon that I spoke about. The other piece that's interesting is that we've really been struggling with floods here in Vermont, which many of you have probably seen on the news. So having even a bit of distance from the ground in terms of flooding and flash flooding has been something that has, turned out to be a fortunate resilience answer for us here as well. We have, so the other foundation types that we've tried that are interesting that we might want to try again are rubble trench foundations, which I don't know if folks are familiar with those, but I think those are really interesting as well. The grade beam and how that's achieved on top of the rubble trench can be done in multiple ways. It can be a poured concrete beam, and if it is, it's way less concrete than you'd use in many other applications. We have also done rubble trenches using like a rot resistant local species like black locust, which I think also has really interesting possibilities and opportunities. So yeah, I hope that answers your question. I know we've been thinking a lot about slabless slabs, which I don't know if anybody here's done a lot of looking into those, but that's another thing that's been kind of fun to look at. So yeah, thank you for the question, Shannon.
Yeah, thank you.
Thanks, Ace. Up next is Julie. Feel free to unmute and ask your question.
Probably the least important question of the day, but does the tile get installed over the plaster finish that you showed?
Oh, I love that question. So I actually trained as a tile setter, so I love that you asked that question. It is not set directly onto the straw. We use a cement, well, actually I've switched to using a magnesium board for my tile setting, but yes, a magnesium board that is like typically conventionally mounted. But the other cool thing that I'll just do a plug for, as long as we're talking about like alternative materials, is that there is this really great product. Of course, now in the moment it's going to zoom out of my head. I'll send it to everyone as a follow-up, but it's a lime-based lime mortar for tile setting that uses this really cool technology that sort of replaces both what the latex additives are doing for us right now in thin set mortars, and then also the cementitious aspect. So the combining lime with this, oh, it's coming to me. It's called graphene, and then I'll remember the product name. But anyway, we've been using that for our thin set mortars, which is nice too, to just find a healthier alternative there as well.
Nice, thank you.
Thanks, Julie. Stephen, you're up.
Hi, Ace. Thanks so much. This is fabulous. I'm going to change my question slightly to what is the transportation cost and finish out cost to what would it, because I find the price numbers that were on those different sizes a perfect solution for affordable housing. And so I live in a rural area. And what's your experience with the cost of getting a seed planted and sprouted and growing?
Ooh, I love it. Yeah, so the seed program is a 3-year program. We designed year 1 to be a startup year. So the first year is like kind of this hardcore, like we pack everybody with information and everybody's saying, I'm looking at a space. How big do I need? Help me figure this out. Like, so we have a combination of like one-on-one coaching with group coaching, actually, with the rest of your cohort. And then we also just do info sessions where we're just dumping a ton of information, like here's how we do our estimating. Here's how we set up our table. These are the, just like, so after that first year, the last 2 years are converting into this collaborative where we're actually, new frameworks will just be a part of this collaborative too. Like eventually, we're basically saying, listen, let's give you everything we can. You all level up to where we got to, and then let's all go forward together. So that's the idea of it. Year 1 is the most expensive part of it because the last 2 years are less so. The total cost of the program is $25,000. And year 1 is, I think it's $20.98 or something like that. And like the next 2 years are like $4,000 something split between each year. So again, we're trying to make it very accessible and affordable for folks to just like get this going. And we've been looking at like the Cooperative Fund of New England and other kinds of cooperative funding opportunities to try to help people access grants or low interest loans or whatever to be able to even do that first year, because I would love for people to be able to do it with even lower of an economic barrier than that. Even though most of us in the business world know like, okay, that's a really low one as it is, but still 25,000 is a lot for people. And especially as you're starting off from nothing. So yeah.
Oh, great. I know that sounds really perfect. And I know that you are super busy, but I'd love to have a conversation with you to get more into the nitty gritty, or if you have something, because I see this as a great workforce training opportunity for our county.
I completely so agree with you on that. I feel like workforce development is the thing that we don't talk about enough. And actually, I didn't mention it all, but I should have, because we, as many of you know, are very short on carpenters for many, many reasons, right? And um, making something that is doable from more of a technician standpoint to me is also critical, because that labor portion and that workforce portion is key to us being able to move forward. So yeah, I love that you said that, Stephen, and totally agree. Yeah.
Great.
And we
Thanks.
have so our page on our website, if folks want to go to our website, the page advocacy page has the seed network introduced in the beginning, and we have a link where you can check out the sort of the curriculum, but we also are building right now like a custom inquiry form just for the seed program, so that people can, you know, custom just write about that, rather than, you know, all the other stuff we do. So
Great.
Yeah,
Thanks so much.
And Inez did drop in the link to the advocacy page, and then Kim put in some contact information for ACE. So feel free to reach out. This is your opportunity. I think we're going to try to sneak in one question before we hit upcoming events. Bev, I think your first question about cost was answered in the chat. So did you want to ask your second question? Do you remember? I have it here.
I can't remember.
It's how hard is it with this design kit for a builder to hit Energy Star and Passive House certification?
Oh, yeah.
Yeah.
easy peasy. Lemon
Easy
squeezy. Yeah. I mean, we've done certified passive houses throughout our career as a company. We actually, I always forget, this is like a fun little feather in our cap, but we built the first passive house in Burlington, actually, which is really cool. And our first straw panel home that we built in Massachusetts in collaboration with an architect named Michael Dobler, if anybody knows Michael, was a certified passive house as well. We have not gone for certification with any of the rest of them, but we do, you know, midstream blower door test at the end, you know, everything, you know, run it all, blah, blah, blah. So yeah, we are at passive house level for certification, or very close practically on most of them. So it'd be very easy to go that like extra, you know, couple miles to make sure it's 100% meeting.
And the reason I ask is in Massachusetts, the Mass Save program for the all electric new construction offer, if you hit passive house certification, then you get 25 grand incentive. And if it's Energy Star, it's 15, right? So Greg knows this at Rare Forms, but like,
yes,
it's a backdoor incentive, not as good as Vermont's, right? 50,000 for an ADU, but like, yeah.
That's awesome. That's great. Yeah. So it's very, very easy to do. And yeah, we can show how that's done. And especially as people have been coming to understand, like, we don't want to penalize small buildings, right? So we need to also look at like CFM 50 and understand, you know, how these numbers are actually working for small buildings. So yeah, I think we're there.
So selfishly, I'm going to ask my question, which is, what's kind of the what's the life of these ADUs, and what happens to end of life? Because when you think about how these panels are put together, it seems like they're natural candidates for disassembly, and maybe the straw has a second life. So I'm just curious what happens there.
I love that. Thank you for that, Shelley. Yeah, I feel like that's formally exploring that and really like getting some, you know, examples or references together is something I would really like to do, and is on Jacob's and my to-do list, to be honest. But what we do know is that yes, they're completely disassemblable. You know, the thing that would be like extant or need to be recycled would be the fasteners, which are metal. Other than that, we're talking about framing, wood fiber board, which does have, you know, some binder in it, and then the straw. And we do pop the strings, so the strings aren't even there. The poly twine is not even there in the walls anymore. And then, of course, depending on whether or not we're using a membrane, like a membrane product for the air barrier, or whether we're using plaster. That is one of the appealing things of the plaster, is that, you're literally just returning minerals back to the earth from where they came. So there's like nothing there in terms of end of life. Yeah, and the straw, I mean, one of my favorite stories of building with straw in Vermont is that we, drove by the field that was growing the straw that then was harvested, that then we built the building with. And then some of the, when you're building with straw, you do have excess, that kind of sheds when you're building with it. And so we always have some just from building it, some loose straw from building the panels. And that went to the farm to be used as like ground cover and mulch for their strawberries. And then we were all eating the strawberries. And it's just like, oh, so like these are the sorts of things that we need to make normal in our buildings, right? Is that we, eat fruit from the buildings that we deconstructed. So yeah.
And then what's the lifespan of the ADU? I'm sorry if I missed that in your, like, is it what do you anticipate the lifespan?
I mean, I don't know. This would be a question for Jacob in terms of like, is there a formal designed,
Right.
lifespan? We don't, as far as I know, I'm not aware of that.
Okay.
But what we've seen practically is like, I mean, there's not a limit on the time frame of a building that's, designed correctly and is maintained.
Maintained, right, of course.
Yeah. And the maintenance, of course, would be the siding, which, so there are exterior layers, the roof, obviously, and then, maintaining our interior air barrier and making sure that's not punctured and, that sort of thing, right? Like throughout. So yeah, I mean, we expect a good long time.
Great.
Yeah.
Thanks, Ace.
Yeah, you're welcome.
Great. Thank you, Shefali. I know you have to go, so we're going to jump right in here. It looks
Good
like
to see you, Shefali.
Dennis is up next. It may have been answered in chat already, but if you want to hop on, love to hear from you. I'll give you just one more second.
Oops, I'm trying to get everything running. Hello, everybody. How are you? Can you hear me okay?
Yes, we got you.
I can't hear myself, so that's fine. I put a picture in the chat for all of you earlier during your program from a post frame straw bale infill that I did back in 09. Might be a fun little photograph for all of you. My question was basically about the panels. Wall thickness?
14.5 inches with the sheathing.
What's
14
the
inches
proposed
without.
or tested R value of that?
Yeah, we haven't personally tested them, which I would really like to do. That's on our to-do list also. What we know is that if folks are familiar with CASBA, the California Straw Bale Association, they are putting out a report basically on R value of our panel type. And it's showing that we're going to probably be closer to the European values that we're seeing, which are R40 to R45. So that's what sort of EcoCocon, actually they list theirs, I believe, people could check on their website, but I think they're at 41 if I remember correctly. Anyway, so yeah, I mean, we have been conservatively using more like R35, just because we did not have that data that we felt like we could really stand behind, and we would much rather be cautious and accurate than overblow and overstate. But I am happy that that is going to be released, and we are seeing that those are closer to the numbers that folks are finding. If people are familiar with Croft in Maine, they're another straw panel producer. I feel like we're in this really awesome moment where we're starting to explode with these techniques and these technologies. And Croft is a producer in Maine who actually heard Jacob also at a passive house thing in Maine like years ago and was like, I'm gonna do that, and went and did it, which is awesome. So we're so happy to have them like in the scene. And they recently tested their walls, and I believe they got some really bananas numbers. If anybody wants to look on their website, like they, and I don't mean in a derogatory way, I just mean they were very high, like R50, like, so R48, that sort of thing. So I think we're at a point where we actually just really need more resources to test these materials and actually have repeatable testing that we can actually point to get a better answer about what contributes to R value, what detracts from it, what are the different factors. And we just don't know enough about these materials.
And I'm not all hung up on that R value anyway, as long as we have this envelope constructed
Airtightness.
properly
Yeah.
with, controlling the air and the moisture, so it
That's right.
doesn't really matter. So you do a roof panel as
Mm-hmm.
well,
Yep.
and a floor panel are the same thickness then?
No, the roof panel we do our roofs are 60. So
Okay.
that thickness, am I going to remember it off the top of my head?
18 to 20.
Yeah, I don't think it's quite that thick because we're using timber HP. Anyway, I can send you those specs if you want, what exactly it is. But we're doing R60 for the roof. And then the floor boxes are 40. So
Yeah, good. I'd like to talk to you sometime later about what it'd take to get one of these things out to Iowa. Might be a trick.
oh, cool. Well, maybe our Missouri people would be right there for you.
Oh, okay. I won't take
It's the
anybody
really
else's
cool
time
thing
right
with our
at the
seed
moment, but
collaborative.
I appreciate
Yeah,
that. I'll try to touch
sure.
base
Yeah,
with you.
feel free to reach out. Yeah, that sounds great. Thank you.
Good day, everyone.
Awesome. Thanks, Dennis. So that's a good segue. The next couple questions we're asking about the fabricators and or cohort participants in Missouri
Oh, nice.
and Maryland. I don't know if you know that off the top of your head or if you want folks to reach out to you directly.
No, I do. So building integrity is our, and I'm going to I'll pull up their website really quick. Their website is buildinteg.com. Here, I'll just share. And they're amazing. They are an architect, Adrian Stolwick of Monarch Architecture, and some other builders and designers who are in their community, who just came together and said, let's do a startup and let's figure this out. And so they literally just started up as a company last year. And they've already, they're go-getters. They're just like Rare Forms in Massachusetts. They don't wait for things, they just do. And so they went ahead and did their first project within the first year of the Seed Network. So they have also a page on the Seed Network. So this is, look, there's me and there's Marina. This is our shop. And this is, our crew mixed with Rare Forms in Massachusetts. So this is Greg Bossy, who's the owner of Rare Forms. This is Adrian here. And this is all of us. We do a week on-site training in our shop where everybody came and we all worked together and, learned installation. So you're seeing here, installation methods. This is me, I think, talking through plaster, yeah. So this is, and what we've done too is saying, okay, so we have our pre-designs that, we've invested quite a bit of our own internal R&D time and money to develop these designs, which are, integrated, high performance, all electric. I talked a little bit about the plumbing challenge of where do you put the plumbing so that you get the proper pitch, so that you can, but then we want a floor that people don't have to step on. It's a lot that we've fussed with, in addition to all the specifications. So being able to actually share the value of those pre-designs internally and be able to say, okay, cool, building integrity can just bust one of these out and send it to Iowa, send it to, Kansas, they're right there. So it helps then, cut down on shipping and actually just more quickly share these ideas and get them to scale. So so that's building integrity. And then I'll mention Rare Forms, which some people, I think Bev, of course, knows, from Massachusetts. But so Rare Form is our other cohort member, and they are also fully launched and have completed their first project as well. And we are going to be tabling with them at NESI, the NESI Building Energy Conference that's coming up. And then our new upcoming members, I mentioned Maryland, Washington, and then this is what happened last time. I was like, who's on the same person? Oh, I know. Colorado, Living Craft. So Living Craft in Colorado, A1 Design Build in Washington, and then Palm Design Studios and Earthbound Builders in Maryland are coming together in the cohort. So
Perfect. Thank you so much.
yeah.
Looks like you've answered all of those questions. So next we have about 2-3 minutes left, so we'll get through as many as we can. But we have a question from James Turner. It looks like you're still on the call, James.
I am, yes. Hi.
Hey, James.
It's a really basic question, but I was wondering how long you have to store the straw bales. Like, do they have to age? Do they have to dry inside for a certain amount of time?
Such a great question. No. Basically, farmers don't want to bale if it's wet. So, they will only do it when it's dry weather. And the reason for that is that if you bale wet straw or hay, anything, pack it into like a tight package and then throw it into a barn, you actually at that point have a risk for spontaneous combustion, because that moisture is going to start to rot and decompose. We'll actually get decomposition going on the interior of that bale, and that can generate enough heat that will actually start a barn fire. So that is why barn fires happen if you have a wet straw bale or a wet hay bale. So it's in everybody's interest to bale them when they're dry. For that reason, farmers all have a moisture meter that they keep with them. We have one too. I don't have a picture of it to hand, but it's essentially just a little, a little digital monitor with a long probe, and you just stick it into the straw bale, hit the button, and it will read the moisture content at the interior of that bale. And so our practice, one thing, because we're using an agricultural byproduct that isn't intended as a building material, you have to do preparation with your farmers to make sure that they understand what a building quality straw bale is. And yes, dryness is absolutely a part of that. So while it is true that it's in their best interest too, we also need to make sure that it's dry, tight, clean, doesn't have other contaminants or other things in it, done to a certain tension. There's a whole bunch of things. So the moisture quantity that we seek in our building quality straw bales is 15% or less. And when we receive the straw bales from our supplier, I was showing the picture of our farmer backing up, with the truck. We check, spot check. We don't check every single one, but we spot check the load when they get dropped off. And almost everything is either 9, 11, whatever in that range. And this is really cool. If anybody wants to go on our website too, we have a free download of this. It's old, so give us a little grace. Like Jacob and I did this, I don't know, like 13 years ago. But there's a study done on all of our straw bale buildings that we had done to that point across like New Hampshire, Vermont, Maine, Pennsylvania, New York, whatever. And we put blower door tests on these things. We did infrared camera imaging. We did pin and scan moisture testing and probe moisture testing. And what we found from that is that the oldest buildings were the driest. So even in buildings where we had things like a roof leak, let's say, that was incidental, that was, on a certain part of the wall, we found that not only did those buildings dry out, so our wall assemblies were drying out, they were not holding on to moisture. And that's where that vapor open, airtight, sealed 6 sides comes into place. And having these, vapor open, but also moisture loving, materials like plaster on the outside really helps us as well. But so we found that the oldest materials were the driest, the oldest straw bales were the driest. We were measuring like 6%, 4% on these older buildings. And this is very dorky, but if anybody, there's a story that Paul Lisinski, that's who I was trying to remember before, Paul writes about in Serious Straw Bale, where they went and took apart an old cob wall in Ireland that had been built 500 years ago. So cob, for those of you that don't know, is clay, a thick kind of mass of clay and sand that has some straw in it as basically kind of a binder, but it's mostly a masonry mix of sand and clay. And this was a very old 500-year-old wall. They pulled it apart, and the straw inside it had essentially fossilized because it had been deprived of oxygen and deprived of moisture for 500 years. So that's basically what we're using that concept, that understanding is what we're using to keep these cellulosic materials dry and healthy over time.
Thank
you. Thank you. I think that'll bring us to the end today. Great place to stop. But I've learned a lot. I know Bev is, a lot of people in chat are just saying how much they've learned today. So Ace,
Awesome.
Any last words from you?
Just thank you all so much. This was such a joy to share and learn with all of you. And I look forward to future connections. Thanks, everybody.